Hello, and welcome to this third chapter of this Blender Multipass Viewport Compositor for NPR tutorial series. In this chapter, we're going to be doing this, which is some experimentation on how to stylize or art direct your depth of field effect. When I'm saying depth of field, I mean that the things that are not in focus in real cameras get blurred or smudged, and how to stylize this or reinterpret this in your style should be a key conversation when doing NPR. And that's something that we can't do in shaders, but we can do in compositing. For this, we're going to be using the viewport compositor in Blender 4.3, which will allow us to do all this in real time and preview it in the viewport, the same viewport where you animate, do your materials, do lighting. You're going to see your effects on top. So that's cool. Let's start. Let's start by analyzing how this is done in some NPR-ish movies. For instance, in Across the Spider-Verse in Gwen's world, they're using brushes everywhere, but as it recedes into space and in areas where there's less interest, they try to have there be no detail, and these brush strokes become larger and become more broad and have less detail on them, which I find a really interesting and a great way to lead the eye towards where the action is happening. Another similar example comes from Mitchell's vs. the Machines, which is an amazing movie. Go watch it if you haven't. And here we can see that as the background recedes into space, they are using some techniques to smudge it and bring it together in a way that it simplifies the background and we get more detail on the characters and less in the environment, which I think it's also really successful. And a different example comes from Lego Batman, which is also a hilarious movie. It's way more photographic, completely different style, but in this case they are using the bokehs, which are the shapes that we see when we defocus an image, to be heart-shaped. And the funny thing about this is that the bokehs reflect the shape of the aperture of the camera. And up to date, I haven't seen any camera that uses a heart shape for their aperture. But it's a fun thing to emulate, and since we're in CG, we can do anything, so why not hearts? And it fits the story because it's a dramatic moment. Bruce Wayne is falling in love. So great movie, great moment, great resource. Now, we're going to be using the viewport compositor, as I said, to do this. So we're going to need to learn a few new nodes to achieve this effect. We can do it a variety of ways. The first way that comes into mind is using the Defocus node. The Defocus node is a node that's built for that. I don't use it because I don't love most of its settings, but it's a good thing to know. Its main parameter is this Z scale, which allows to drive kind of the size of our defocus. And then it has several types of bokehs. And that's something that already our default cameras in Blender can't do, but we can do it through compositing, which is cool. And of course, this is not taking into account our depth, but as you can see here, that's not going to be an issue, and I'll cover it later. But if you're looking for more bokeh customization, my way to go is using the Bokeh Blur. And the Bokeh Blur may look like your normal blur. It has this size parameter and other stuff, but the key thing here is that it has this socket, which is called bokeh, and we can plug any image to it. Blender comes with this node that's called a bokeh image, which is basically a generator for bokeh shapes. You can choose the flaps, the angle, rounding, and all of this you can plug into your bokeh socket. And now we can see that the bokeh we designed is now applied on top of our renders. And you can go crazy with this lens shift, and you can do things that are very, very trippy. But my way to go is actually using custom images. If I want to do something crazy, I have an image here of the Blender logo. I've run it through a node to do a binary thing, and I can plug that into my bokeh. And now we can see we have Blender shaped bokehs and a Blender defocus node. And we'll also cover later how to have that driven by the depth so that we can select a focus plane and have things defocus according to that. There's a couple more nodes that might go into the crazier realm of defocusing, but I want to cover anyway, which are the Kuahara node. That I'll be fast here. We've talked about this before. It's a node that basically tries to simplify our image and looks for neighboring pixels in similar areas to simplify our image. And you see, as we go crazier and crazier, it simplifies more and more. We have some parameters here to drive the sharpness of what it's doing. And we'll also be able to drive the size by our depth. And another node, which is actually my favorite, that we can use to blur stuff in fancy ways, is the bilateral blur. And this might also look as a regular blur. It's no different than what we've seen in our Bokeh Blur, but instead of a bokeh socket, it has this determinator input. Now, what is this? First, we have this space sigma, which will be kind of our size of our blur, but our color sigma is related to this socket here. The determinator is basically an image you can feed it to tell him in which regions it can blur within. Let me explain. Allow me to explain. I have this image, which is kind of a watercolor-ish set of colored regions. And if we feed it to this determinator, we can see that it now blurs, but it lets through this pattern that we've fed it. And what's happened is that the pixels that are within a region will only be blurred within a region. So they won't sample pixels from other regions from that are not from its own. And this color sigma is a parameter that allows us to say how similar a region has to be for it to consider it so a part of its region. And you can see as we go further and further, like higher, it becomes a softer result. And if we go really, really low, we can see that's something very harsh. And it doesn't have to be colors. It can also be black and white. I painted this set of brush strokes in Krita, and I can plug it in here. And we can see we now have brushy blur. And you can see as I lower the color sigma, we make it harsher. And the fun thing about this is that you don't have to use one or the other. You can combine these textures, these determinators, into a fancy image that that is very artistic. For instance, if I add these two images and plug it here, I can see I have a bit of both. The watercolor and the pencil textures are showing through in a render, and now it's looking a bit psychedelic. But the fun thing to note here is that it's not looking for a readable image. That would make no sense to me, but the node is just reading differences between the pixels. And we can get, as you see, fun things. And this is a great moment to remind ourselves that this is live. We are seeing this on top of our viewport, and we're seeing this in real time, but it may introduce some temporal inconsistencies. You see, as I orbit around these textures, which are in screen space, we can see that they're sliding through a bit, and that might not be the look you're going for. And there's a solution for this, and it's actually using custom textures that you set from your materials. How do we do that? Well, there's this shader AOVs that are very useful for this, and we set them up in our shaders. Let me reset my image and go to my shader editor. If I enable my overlays, I can select my character, go to its material, and you can see it's a regular material, nothing fancy going on here, but I have this set of textures here. Using my UVs, I'm projecting the same watercolor texture that we've seen before. I'm projecting it to its to its geometry, and since it's using the UVs, it's tracking with our object as we move the view, and that's not an issue. We'd love to have a way to promote this texture not to the materials which are evaluated before the lighting, but to the compositor, which happens after lighting. And the way we have to do this is by using an AOV output. This node will allow us to do our custom AOVs. We've used the depth, we've used the normal, we've used cryptomats, the diffuse color, but you can also, through materials, create your own render passes. And the way we do that is by, again, using the AOV output and naming it. I'm gonna be calling it mask. And now, the only other thing we have to do, besides bringing its material back and going back to the compositor, is enabling this mask AOV that we've now created. We're gonna go to the view layer and to our render passes, and under shader AOV, which you can probably not see because my face is in here, we can hit plus and name this AOV, in our case, mask. And by doing this, we can see we have now a new socket in our compositor. And if we view that socket, we can see that this image that we've defined is now part of our render layer. And yeah, it works. And if we plug this to our determinator and preview this, we can see that it's blurring based on this mask after the lighting has happened, and it tracks with the view because it's using the UVs from the material. Crazy the amount of things we can do. That's a lot of control. I'm gonna bring it back to the original textures we were using and answer the main question you all must be having now. Okay, that's very pretty, but how do we make it depend on our depth of our image? How do we actually focus our stuff? So I'm gonna go back to our defocus node here, and this is how we left it. And for that, we're gonna be using our Z parameter. If you plug the depth to your Z, we can see before, after, something changes. These things in the foreground have gone smaller, and the thing is that it's using the value of the depth to drive the size of this blur effect. So as it gets closer to the camera, it gets closer to 0 and the blur gets smaller. But that's not really what we want. We want the blur to be smaller as it gets closer to the focus object. And the way we do that is by doing some math before our Z input. We'll need a subtract node, math node, and we're gonna need an absolute. We have it here. Aha. Now, the subtract node will slide what's 0 in our scene around. So as I subtract a value, different areas of our scene become 0 from our depth, and the absolute will make everything that's a negative value will make it positive. Basically like ping-ponging with 0. And you can see we can slide this darkness, which represents the 0, which means it's not gonna blur in this area. And if I now plug this into a Z parameter, it gets now our character is in focus and everything else is defocused. There's some issues, but I'll come to it in a second. You can see if I copy this and bring it into my Bokeh Blur, depth, subtract, absolute, and plug it into a size, we'll be now getting some weird things. And that's because we need to first check this variable size checkbox, which will tell it that the size is not a single value. And now, yes, we're getting weird stuff. We might need to increase the maximum blur. I'm gonna go with 50, but still we could be getting some weird things. And the thing is, we'll need now a way to tell it how much do we want to blur, because now our size is gone. And the way I do that is by using a multiply and here, and basically decreasing our blur. And we can now see we can slide still our focus around and have it be blender shaped, which is crazy. But I want to take a second and acknowledge that this is not mathematically correct. Let me explain. Say I were taking a picture of a person, like a portrait picture. Here, let me draw a person. Tremendous drawing skills. Hey, and she's happy because yay, nice. And you have some trees in the background. Yay, trees. And then you have some clouds on the background. Clouds. Now, if you've done any photography at all, you'll know that when making the focus be our subject, everything else will be out of focus. And not only out of focus, but it'll be in a similar amount of defocused. And the way we're doing this now is that we're doing as it gets further from our subject, it gets more and more blurred. And you can see that's not really how things happen here, because if I were to represent this scene, I would have my character here, my camera here, some trees in this background, and then much further there would be some massive clouds, and you could see that the this and this appear semi equally blurred in the image, but they're definitely, the clouds are way farther than from our camera that the trees are. So some of the math has to be wrong here, and it indeed is. I've done my best to approximate the math of how this works, and I've come up with this, which again is taking the focus distance into account, is taking our distance from the camera, is taking our size, our scale here, and trying to do its best to approximate it and to fix some of the artifacts that it produces. And I've made this into a handy note grip that you can use and you can download in the description. So I'm going to be using this going forward. See, if I copy these and I bring it into my Bokeh Blur example, let me paste it, delete this, and bring it in here. Sorry, depth of field. We can have this preview input to make sure that everything is in focus. It is. And it now works in a way that's maybe more natural. You can increase this. I'm going to go for 60 maybe. And as we slide this value around, you can see it has a bit of a more natural response to this. I think that's very cool. I could do that forever. But yeah, we've emulated a depth of field strictly in compositing, where we can change our bokeh image. How cool is that? But it can be cooler than this, and that is if we use the depth to drive our size of our Kuahara. So what this is going to do is similar to our Across the Spider-Verse reference. This is going to simplify what's not in focus, but keeping some sharpness in it. So basically reducing high frequency detail. So let me set up my focus distance and plug this depth of field to my size. And by default, it's not doing much. That's because we need to crank this scale to a lot. I found that with Kuahara 400 works, and see how now we're losing lots of the detail, the cable, and we're simplifying these shapes but retaining some of the sharpness, which I find really cool. And we can still slide this focus plane around and it gets very nice effects. I love it. And what's a bit more complicated but super rewarding is to have our bilateral blur be using our depth. See, our bilateral blur is using this determinator, this image that now isn't having any information about our scene. And you could try to drive our size, our space sigma, with our depth, but we can't because there's no socket in here. So a hacky way to go around this is to use some data passes to inform our determinator. See, the thing is, if I add the normal and the color, I can branch this out. And this are passes that have information, one about the geometry of the scene and the other about the colors or a bit of the materials of the scene. So if we add them both, we can see we get a pass that, when used as a determinator, constrains the blur to the shapes and the geometry that there is. And you can see it clearly if I decide to add it to the previous image that we had, this organic brushy image. And see that as I add this, the image gets sharper. Aha! And that's going to be the key of what we're doing. Let me find a bit more space. And just here. And let me add this depth of field node. And I'm going to use this to drive this slider here. Now, as it is, it has values that go above 1, and that's not good for masks, as I explained in other chapters. But we can use a map range node to establish kind of a mask. And what we need to know now is that when this is 1, it gets sharper. And when this is 0, it gets blurrier. So here we have 0 where it's sharper, like the focus area. So we have to first invert that. So 0 to be 1 and 1 to be 0. And if we now plug this clamped, because it's a mask, we now get this, where we can slide our focus plane around and have our image get sharper and less sharp. It's not that obvious now. What I like to do is to add a power node that will basically ease a bit this transition. And now it might have, oh no, the other way around, say 2. And it will now have, I think, a prettier fall off as it goes in and out of focus. I love this. I could do this all day. The only thing that I'm going to do to make it prettier, see, now we're introducing a lot of high frequency detail. And one way to get rid of that is using the Kuahara. The way the Kuahara is actually intended to be used to reduce high frequency detail. And maybe 4 will do. And that will get rid of most things. And this is the way we can now get a painterly, very pretty depth of field effect. Over blurring will help a bit, but yeah. And that's a bit of all that I have for you. I'm gonna keyframe a bit of these values to convert it into this demo that you saw earlier, and I'm eager to see what you do with this. Make sure to tag me on my social media. They're linked down below if you do any of this. And make sure to follow me to the next chapter, which is going to be me using all this knowledge to try to replicate some effects from Miles' world in the Spider-Verse and doing the best that I can. See you there. Thanks for watching.